Hello everyone, myself Hans. Today we are going to solve the problem of UPSC 2024 15 marks question. Here in the question, using Gauss divergence theorem, evaluate the integral double integration of surface y square I plus xz cube j cap plus z minus 1 whole square k cap dot n cap ds over the region bounded by the cylinder x square plus y square is equal to 16 and the planes z is equal to 1 and z is equal to 5. Let's solve the problem. Given integral is y square I cap plus of xz cube j cap plus of z minus of 1 का square k cap dot n cap ds, and the cylinder is given by, and the cylinder x square plus of y square is equal to 16 and plane is also given. Plane is given z is equal to 1 and z is equal to 5. This is the plane. We have to use Gauss divergence theorem, and the Gauss divergence theorem is given by Gauss divergence theorem is given by double integration of f vector dot n cap ds is equal to integration of divergence of f into dv. This is the Gauss divergence theorem, and from here we have to comparing the given integral, that is in place, we have to in place of f is given by, f vector is given by y square I cap plus of xz cube j cap and plus of z minus 1 का whole square k cap. From here we have to find the divergence of f, and divergence of f is given by, that is del of del x I cap plus del y of j cap plus of del y del z of k cap dot product into y square I cap and plus of xz cube j cap and plus of z minus of 1 ka square k cap. We have to find the divergence of f from here, that is del of 1 del x, this is the not the coefficient of x, this is 0, and for y the coefficient is not present, this is also 0, and for third del upon del z, that is 2 times of z minus 1 is the divergence of f. We have to put in the Gauss divergence equation. Let this equation 1 putting, we have to find, we have to put here, that is divergence of f is, we have to calculate 2 times of z minus of 1 and dv, and dv is given by dv is given by, that is 1 2 triple integration of 2 times of z minus of 1 dx dy and dz. We can also solve the given integral with the help of cylindrical coordinates, but we have to not use their cylindrical coordinates. Further, we have to solve. We have to put the limit of x, y, and z, and from the cylinder, we have to find the value of limit of x, that is x square plus y square is equal to 16. When we put x is equal to 0, y is equal to 0, y is equal to 0, then we have to find the x square is equal to 16. Then we have to write, that is x is equal to plus minus of 4. And further we have to find the limit of y from here, that is y square is equal to 16 minus of x square is taken into right hand side, that is minus of x square. And further we have to also write y is equal to plus minus of under root 16 minus of x square. And the limit of z is given by the plane 1 to 5. Here we have to put it, that is limit of x is minus 4 to plus 4, and limit of y is minus of under root of 16 minus of x square and plus of 16 minus of x square. And the limit of z is 1 to 5 given by the plane, and the divergence is already present, that is 2 times of z minus of 1 dx dy and dz. We have to solve the given integral. Solving given integral by, first we have to integrate with respect to z, that is 2 is taken into outside, and we have to half of the limit taking, that is 2 times of the minus 4 to 4 is taken into half of the limit, that is integration of 2 into integration of 0 to 4, and again we have to take in minus to minus in half of the limit, that is again we have to write 2, that is integration of 0 to under root of 16 minus of x square and z minus of 1 and dz dx dy. We have to first integrate with respect to z, that is 2 to the 4, 4 to the 8, 0 to 4, and integration of 0 to under root of 16 minus of x square. On integrating with respect to z, that is z dz is z square by 2 and minus of dz is z. We have to put the limit of z, that is, one second, we have to put the limit here. Limit of z is 1 to 5, and we have to put 1 to 5 dx dy. First we have to put the upper limit, that is 8 times of 0 to 4 and integration of 0 to 16 minus of x square, and we have to put the limit, that is in place of z we have to put 5, that is 25. Once again we have to fill the marker. In place of z we have to put the value of 5, that is 5 5 is 25 upon 5 5 is 25 upon 2, and in place of z we have to also put 5, and when applying lower limit, that is in place of z we have to put 1, that is 1 by 2, and in place of z we have to put also 1, that is minus of 1, dx dy. Further we have to solve, that is 8 times of 0 to 4 integration limit and 0 to under root of 16 minus x square, and we have to solve here 5 to the 10 and 25 minus 10 is 15 upon 2, and minus of here 1 by 2 and minus of 1, that is minus of 1 by 2 and minus of is already present, that is plus of 1 by 2 dx dy. Further we have to write, that is 8 times of limit 0 to 4 and 0 to under root of 16 minus x square, and from here taking LCM is 2 and 15 plus 1 is 16, 16 by 2 is 8, that is 8 dx dy, and from here we have to integrate with respect to y, that is, and 8 is taken into outside, that is 8 is just 64, integration limit is 0 to 4 on integration of dy, that is y, and applying the limit, that is 0 to under root of 16 minus of x square. Further we have to put, that is 64 and integration limit is 0 to 4, and here we have to put the upper limit in place of y, here is dx is also present, that is under root of 16 minus of x square dx, and we can also write the 64 limit 0 to 4, and this is 4 squaring of 4 is 16, and that is x square dx, and we use the formula, that is integration of a square minus x square dx is given by x by 2 under root of a square minus x square plus of a square by 2 and sine inverse of x by a. We have to must remember these identities to solve further, and we apply the following identities, that is 64 on integration, that is in place of x, one second, in place of x, that is x by 2 and under root of a square minus x square, that is 16 minus of x square and plus of a square, that is a square is 4 ka square, that is 16 upon 2 and sine inverse of, in place of x we have to put x and in place of a we have to put 4, and applying the limit 0 to 4. Further we have to apply the limit, that is 64 and applying the upper limit, that is in place of x we have to put x we have to put 4 by 2 and under root of 16, in place of x we have to put 4, that is 4 4 is 16 plus of 2 8 is 16, cancelling on, that is 8 plus sine inverse of, in place of x we have to put 4, that is 4 upon 4 is 1, and when applying lower limit all are 0, then from here, that is 16 minus 16 is also 0, then the remaining is Then the remaining is integration of f vector dot n ds is equal to, here is 64 and if this function is 0, then this is 8 sine inverse of 1, sine inverse of 1, and sine at the value of sine 90 is, sine 90 is 1, that is 64 into 8, and sine inverse and sine pi by 2, the value of sine pi by 2 is 1, so from here that is 64 into 8, and here is pi by 2, from here we have to cancel out, 2 4s are 8, then double integration of f vector dot n cap ds is equal to 4 into 64, that is 4 4s are 16 and 4 6 are 24, 24 plus 1 is 25 into pi. This is the required solution of the given problem. Thank you class and thank you for watching. If any doubt, kindly comment in comment section.